All right, so if you watched the previous video explaining what the ambiguous case is, side-side angle, we talked about that there are two different possible lengths for side y when x is 5 centimeters. You can see that there would be one possible length for y when x is 9 centimeters, and then no possible lengths for side y if x was 3. So we're going to go through the proof of that and actually find what side y would need to be, which then would prove how many possible triangles there are. The first thing that we're going to do is set up the law of cosines. And generally when we're using the law of cosines, we use it to find a missing side length, which is still our goal. So we know side 5, we know the angle across from it's 26, we know side 8, and what I'm looking for is side y. So we would normally set it up in this way. Y squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of the angle across from angle y. Well, unfortunately, the angle that I know is across from the side x. The angle across from side y is changing. And so since I don't know that angle, I'm going to have to set up my law of cosines a little bit differently because right now I have two unknowns. What we're going to have to do is set it up with the 5 squared by itself because that's the angle that I know is the one across from the side squared. So I'm going to have this as 8 squared plus y squared minus 2 times 8 times y times the cosine of the angle across from the 5, which is the only known angle, which is 26 degrees. And so we're still using the law of cosines, but we're setting it up a lot different than how we have done in the past. From here, we can rearrange this. 5 squared is 25. 8 squared is 64, so I'm going to subtract over that 5 squared. I'm going to list this y squared first. Negative 2 times 8 is negative 16, and then remember, cosine of 26 is just a number, so I'm going to combine that with that negative 16 and just move this y to be after that, and 8 squared minus 5 squared is 39. Now that I've rearranged this, this looks like a quadratic where this coefficient is just a little bit uglier than what we're used to. And so treating this like a quadratic, we're actually going to see that this is a, which is 1, this negative 16 cosine of 26, and then this 39 right here is our c term. So we're going to use the quadratic formula by plugging in a, b, and c. So the unknown side length y will be equal to negative b, so negative 16 cosine of 26 degrees, plus or minus the square root of b squared, so negative 16 cosine of 26 squared, minus 4 times a times c, all over 2a. 2 times 1 is just 2. So again, we're searching for possible lengths for y. We set it into the law of cosines. However, to find y, it ended up giving us what looks like a quadratic, and so we're going to use the quadratic formula. From here, you just want to be careful on how you type this in. You could do it in a couple different ways. Right here, I have a negative, so I know that that'll just be positive, so 16 cosine of 26. I'm going to go ahead and add these together first. Here's the square root of negative 16 cosine of 26, end your parentheses, squared, minus 4 times 1 times 39. I'm going to go ahead and hit enter. Then I'm going to go ahead and divide that answer by 2. So one possible answer for y is 10.754 centimeters. My other answer would come from subtracting these. So I'm going to go ahead and go back, and I'm just going to grab that entire answer. So now that I have that entire answer, I'm just going to change this to subtraction to find the other possible solution. And again, we need to divide this answer by 2. So my other possible answer for side y would be 3.626 centimeters. And since both of these answers are reasonable, this also is a way of proving that there are two possible triangles. And these would be the two answers here. You could go back and look at your picture to reason through this. This answer right here would be about the 10.7 centimeters. This answer right here would be the 3-ish centimeters. And so those are two possible lengths for y. Okay, now looking at the 9 centimeters for side x, we know that there's only one possible triangle. And so we'll look to see what the quadratic formula would show us here. Same idea, except now instead of this 5, we're going to have a 9 squared equals 8 squared plus y squared. Everything else is going to stay the same. Again, we want to rearrange it to look like a quadratic, so I will have 0 squared equals y squared minus 16 cosine of 26y. And then 8 squared minus 9 squared will end up giving us a negative 17. So the a again is going to be a 1. B is staying the same. The only difference is going to be c, which is now a negative 17. So again, you'd plug this into the quadratic formula. I'm going to go ahead and separate these real quick. So I will end up with y equals a negative negative, so again that's just going to be positive, plus or minus the square root of that b squared minus 4 times a, and again the only difference was this c, so negative 17 all divided by 2. So since I already have this typed into my calculator, I'm just going to arrow up and grab it to save some time, and I'm going to change this to a negative 17, divide that answer by 2. So one possible answer that I get is about negative 1.1 centimeters. To get my other answer, same idea, I just need to change this to positive, adding the numerators. So we'll arrow over, change this to plus, and then we'll divide that answer by 2. And we end up getting our other answer is 15.479 centimeters. Now if you look at both of these, one makes sense. Clearly the 15.479. This answer is negative, doesn't make sense in this context. So we're going to reject this answer. This is a way to prove that there is only one possible triangle. There's only one length for y that makes sense. And if you look back at our diagram, when x was 9 centimeters, y was pretty large, so 15 seems like a reasonable answer. The last possible case is that we have 0 triangles, and that occurred when x was 3 centimeters. So we're going to go ahead, set up the problem again, where this is 3 squared equal to 8 squared plus y squared minus 2 times 8 times y times the cosine of the 26 degrees. Rearrange everything. We will end up getting y squared minus 16 cosine of 26 degrees times y, and our c value will now end up being 55. So our a is again 1, our b, same thing. The only difference now is c is going to be a little bit different. Now with this one, same thing, you'd end up setting up the quadratic formula, but the one thing that I do want to point out is when you simplify what's underneath the radical, we're going to end up getting a negative 13.19533 roughly, and all of this would be divided by 2. So instead of typing this all into my calculator, which you would get an error anyways, just simplifying what's underneath the radical is negative, which means we're going to have no real solution. So since this guy is negative, that means that we have no possible triangle. So there aren't values of y that we can find, and again this matches what we already knew from the sketches that we made in class. Okay, this is a little bit tougher of a way to prove 2, 1, or 0 triangles just because this math looks a little bit uglier. However, if you were asked to find the side length of y, this is the method that you would want to use. In the next video, we're going to use the law of sines to prove how many triangles. That method might be a little bit easier if your task is to prove how many, but again, if you're trying to find side lengths for y, you're going to want to use this method.